for exercise number 3, we need to convert 240 degrees into a radian measure. We want to leave our answer in terms of pi. Basically, that means that, okay, so let's write this down. You need a pi in your solution. Okay, so that you need to have pi in there. So at the end of this whole thing, if you don't have a pi in there, you did something wrong. Now, don't go off of just memorizing the unit circle here, or memorizing these angles. I want to see your work, and I want to see you convert this. So here's how we're going to do that. We have 240 degrees, and we're going to multiply that by degrees on the bottom and radians on the top. And so we know that there's 180 degrees in pi radians. So what's going to happen here is these guys are going to cancel out. So we're no longer working in degrees, now we're working in radians by doing this conversion. So what we're going to have is 240 pi over 180, and now we're in radians. So let's just do some division here. That's 24 over 18. And we can divide each of these by 6. So when we divide the top by 6, we're going to get 4. Divide the bottom by 6, we're going to get 3. Okay. So I want you to look at this. This answer is the reduced form in terms of pi. If I ask you to do something that doesn't have pi in it, all you have to do is multiply that out. So you would take the following. You would take 4 times 3.14, and then you would divide that number by 3. You get 4.18, let's say 4.19. So let's, okay, so this is the answer right here for this question. Not in terms of pi. You would have this value, 4.19. So let's be very clear on this. Pi is a number. It's not a unit of measurement. So what this means is that I could do the following. Okay, so hopefully you're still paying attention to this video, even though we got the answer out, because this is important. What we're saying is that at 240 degrees, so this is 180 right here, so 240 is going to fall somewhere down here. I'll just draw that out in a different color. We'll call it theta. So this is 240 degrees. When I get an answer out like 4 pi over 3, which is essentially 4.19 radians, what that means is if I take this radius length, so I'll grab it here in red, if I take this length right here, and I pull it off and then I start wrapping it around the circle, we would go once, so here's one radius, we would go twice, we would go 3 times, let's see here, that's going to fall just below here, we go 4 times, and then we would go, here's the 0.19, so 0.19, here's 1, this is 2, this is 3, this is 4, and 0.9. So what it means is we can lay the radius out about 4.2 times roughly around the circle, and that will give us the same angular measure.